We'd like to find the antiderivative of 1 over 3 minus 2 cosine of x. So again, for this type of antiderivative, for this type of integral, or this type of function that we're going to find the antiderivative for, you're going to use the substitution x is equal to twice arctangent of u. Okay? And watch my previous videos as I develop on this equation to find the cosine of x. Right? In this case, we just need the cosine. In the previous video, we also needed the sine and the cosine. Right? The cosine of x, and I'm not going to derive it for you, I'm going to go straight to the point, is equal to 1 minus u squared over 1 plus u squared. And again, if you want to see how I derive it, go to the previous video, the first video of an example similar to this where I discussed the sine and cosine. Now the dx is going to be the differentiating this part, right? Which is going to be what? 2 over 1 plus u squared du. Okay, so that should be clear. So as a result, this integral is going to be what? The dx is going to be that, right? So 2 over 1 plus u squared. We'll put the du in the end, and then 1 over 3 minus 2, the cosine is this, right? 1 minus u squared over 1 plus u squared du. Right, so what are we going to have? We're going to get 2 over 1 plus u squared times, let's put parentheses around this part. No, actually brackets would be better. That's going to be 1 over, so let's see, so that's going to be 3 plus 3u squared minus 2 plus 2u squared, I believe, over 1 plus u squared. So 1 plus u squared, since it's the denominator of the denominator, it goes on the top, right? So let's write it here, 1 plus u squared du. So what are we going to have? We're going to have, we can cancel this out immediately. So let's place 2 here. If we have a fraction, we'll put the bottom number here. So 1 over 3 minus 2 is 1, right? 3 plus 2 is 5. So 1 plus 5u squared du. Notice that now you can make the substitution v is equal to radical 5u. And why am I doing that? I'm doing that for the potential arctangent result of the antiderivative, right? Because if we let this whole 5u squared be v squared, then we will have set up an arctangent antiderivative as a result, right? So dv is going to be what? Radical 5 du, right? So as a result, there's no radical 5 in the top, right? So we have to have a radical 5 in the bottom. So 2 over radical 5, we will have 1 over 1 plus v squared dv. Right, so that's easy. This is going to be 2 over radical 5 arctangent of v. v is radical 5u. Radical 5u plus a constant. But we need to have everything in terms of x. 2 over radical 5 arctangent of radical 5u, but u has to be in terms of x. How do we derive u? Well, we can derive u using this part, right? So we know that x was equal to twice the arctangent of u. So x over 2 is going to be arctangent of u, right? Dividing both sides by 2. So that means if you apply tangent of both sides, you will have u isolated on the right side. I'm putting this on the left side just for convenience, and then this part will be tangent as well, right? So tangent of x over 2. Beautiful, right? So this is going to be radical 5 u, so u is this, tangent of x over 2 plus a constant. And if you want to simplify this, you can put this as multiplying both numerator and denominator, rationalizing the denominator, right? You want to make this 5, and this is going to be 2 radical 5, right? So 2 radical 5 over 5. That's another way of putting it. 2 radical 5 over 5. That's the same thing as 2 over radical 5. Right? And there's nothing you can do here because this is not a double angle formula. This is radical 5. This is not a 2. So there's nothing really you can do. This is the simplified answer that you're going to get for this antiderivative. Thanks for watching. Hope this was helpful. See you in the next video.